Very good morning to all of you, and welcome to this live interactive session of the NPTEL course Transition Metal Organometallic Chemistry from Principles to Application. As has been the tradition in this live interactive session, we take up any questions that you may have regarding the lectures which have been telecasted, and we request you to provide your question in the chat box below, and we will take it in the queue or the order in which we receive this question. By this time, by today, you must have finished all the 60 lectures. So before you go on to your final exam, you can, if you have any queries, you are welcome to send it to us through chat, as has been the purpose of this live session. So with that, I see Bikash already joined in. So very good morning and welcome to this live interactive session, Bikash. If you have any question, please write it. Vinylidene complex is sp2 or sp hybridized. Is that the question? This is regarding which lecture that you have. Now, see, if it is in, anything in, then it is sp2. And if it is wine, yne, then it is sp. And it has several binding modes. I think this has been explained in details in the PowerPoint presentation. In the PowerPoint presentation. So you should refer to that the presentation. So anything in means olefin. So that will be sp2. And anything ine, that will be sp. So there is another query which we have received, which was regarding providing any model test paper before your exam. An answer to that is, if somebody, please refer to all the assignments. We have given about 10 assignments, and the questions would be exactly similar to what has been given in the assignments. Please refer to that for your exam. Is there any negative marking? To my knowledge, there is no negative marking in the exam. But there are certain questions which are single correct answer and certain questions with a multiple correct answer. For the multiple correct answer to get the full credit, you must score on all the choices correctly. So do you have any other question, Vikash? Did you understand what's been said? That sp2 hybridized for vinylidene? You can refer to the lecture and PPT, then I can. The binding modes of these ligands were given, no? In lecture number 8, time. Time. Please refer to lecture number 8, where the binding modes of all these ligands were discussed in details. For is there MSQ and MCQ is particular section? Yes, they are separated. There are two sections, section A and B. One will be for MCQ, another will be for MSQ. But please remember that MSQ can also have a single correct answer. That is also possible. So MSQ does not guarantee that more than one answer is always correct. So it is one or more than one. That is how it will appear in MSQ. So MSQ may have multiple correct answer, as well as some MSQ may have single correct answer as well. Uh, Usually, the MSQs which has single correct answer, but it falls in MSQ, those questions are of little bit harder standard than simple MCQ where it is single correct answer. Okay, so lecture one at 21 minute is where lecture 8 at 21 minute is where these binding modes for these ligands are given. Are you a professor at IIT? Yes, I am at the chemistry professor at Department of Chemistry at IIT Bombay. This course is provided from IIT Bombay, from the content which are taught at IIT Bombay. So there would be no negative marks, as somebody has asked, and so feel free to attempt questions. But having said that, it should not be something which is fully statistical, or you just click on everything randomly. Oh, sir, can you previous years actually the assignments? Please refer to the two things. Anything and everything would be asked would be exactly from the content which has been shared with you. That means I mean the tutorial videos, the lecture videos, as well as the assignments. And there is no additional thing that I can give which will uh, uh, help you out further. So all I have to say regarding providing model test papers or model questions, please refer to the assignments and read the content very carefully. Look at the slides and read the content very carefully. Usually, I would think that the slides be more helpful than reading the book which have been given over there, because these slides have been made from the uh, reference books. If you want to read the book, that's well and good. That's very good, obviously. But then you have to do a lot of reading. Whereas if you want to take the summary which is extracted out of the book, that is where these slides and these handwritten diagrams would help you out with. Please go over the lectures extremely very carefully, and refer to the assignments. One thing I can share with you, that there is no subjective questions. So these are all machine gradable ORS response sheets, where you will just select in the correct answer, but you don't have to write long, elaborate answers for this exam. The primary, I would like to have it that way as well, but primary objective over here had been to test the knowledge of the student in the particular area, and within the uh, purview, this would give us the most uh, uh, from most out of it, to get to know what you know or what you have read. The basic idea for this course also used to provide you with an introduction to the area of organometallic chemistry. Organometallic chemistry had been a very exciting field for the last 70 or 80 years, and you'd see that consistently about 8 or 9 Nobel Prizes have been awarded to the domains which are directly or indirectly connected to organometallic chemistry. And transition metal, their applications in catalysis have played a pivotal role. in bringing about a larger benefit to the societal problems. And despite the challenges that are associated with organometallic chemistry, particularly with respect to their synthesis and handling of the compounds, this field is alive, kicking, and quite challenging. So overall aim of this course, as well as two other courses which are run in order even semester, in this including two courses will run in the autumn, summer, no, in the spring of 2025, two other courses. So these three courses taken together will provide you the state of the art development, as well as the key principles and founding principles of organometallic chemistry, so as to arise your interest in this area. Yes, so well, yeah, once again, for people who have joined in late, let me welcome all of you to this live interactive session of this NPTEL course, Transition Metal Organometallic Chemistry from Principles to Applications. This is a live interactive session. If you have any questions, like some of you are asking about the pattern of questions or the model, whatever queries you have, please type in or key in it in the chat box, and we'll answer them in the order in which we receive them. I'm extremely happy and pleased to see all of you join this session, because this also gives us an opportunity to connect with you, if not physically, but through online. And many times it so happened that many people who have taken the course, we have had occasions where I met the student personally, and that is a very pleasant surprise. Somewhere we go down to some university for a talk or something, and the student walks up and says that the student had been taken this course. And more rewarding is that if somebody really feels that the course material has benefited the person, that is the most rewarding experience through this NPTEL. Please suggest masters in IITB versus American, like Yale and Ivy League. Okay. Probably I would answer it this way. We have a very competitive master's program, and so is Yale and Ivy League. In some notch, uh, they are also like, see, something like you got to see if a school which has been in business over 2 or 3 centuries, and they are known for they are reputed for their master's program, and they are regarded globally for their, so those are indeed very prized or prestigious program to be in. And as far as IITB is concerned, we are probably the best right now in the country, and we are comparable to them, but I would not say that we have overtaken them, or and that I would rather ask you to refer to the global ranking, and the ranking would tell you where each of the institutes are. But we are no less competitive than them, but they are known to be the yardsticks or the benchmark of fine education. See, all of you should also realize that chemistry is an applied experimental field. So the program in which you would enroll in would also depend on the funding the university or the institute has in terms of getting student exposed to the modern equipments and all. I must say, probably we have the best facilities or infrastructure within the country, but very high-end universities that you are referring to, they have much more resources, much more funding, very much well off than what we are. Having said that, see, the other thing you got to realize that infrastructure, facility, funding, they can only matter so much. And then what matters more is the aspiration of the candidate. So there may be, if a candidate is aspirational, ambitious, and hardworking, uh, they may do wonders from the university where they get support than from a lot of elite universities. So there may be a lot of people who have gone to elite university programs may not do well in life, whereas there may be people who have done fantastic in from a program which is not so elite and reputed as them. So in the end, it boils down to the individual aspiration, ambition, and how much you want to pay for, or through your labor and hard work and uh, sincere efforts, how much you are ready to pay for the program that you are enrolling in. In the end of the day, actually, one thing I must tell you that from my experience, what matters most is the aspiration and the ambition. Uh, if one has a very intense aspiration and ambition, no other thing sort of works out. It works out in the favor of the candidate. If somebody doesn't have fellowship, maybe the university, in many cases, provides fellowship to the candidate. So the deserving one make their way through, and the ones which are not so deserving, or if we are in a place, they sort of lose steam somewhere down the line. So one thing which drives one forward is the aspiration, and how sincere are you towards, or faithful or honest are you towards your aspiration. So we are having some questions which are off the track, but feel free to ask any questions that you may have. These are also important questions, because right now is the time for you when you're going to when you're going to uh, invest invest next 5 or 7 years of your life for some cause which will uh, build you up professionally, and from where you will begin your livelihood. So it's very much important for you to realize, or at least think about what you're going to be doing. And from that perspective, these questions which you have asked are relevant and important, and I think all of you should ask it. And also you should analyze. But once you decide on whatever you want to do, then it's just 99% perspiration. So you have to uh, work your way through uh, till you reach your goal. How many? Yes, there will be 100 questions. 50 in one section, 50 in another section. 50 plus 50. 50 MCQ and 50 MSQ. But MSQ may have, harder MSQ may have single correct answer. So you would not know for sure how many questions would be there. Uh, how many correct answer options will be there in MSQ? It can be one or more than one. Actually, one thing I can tell, that there will be no question where zero options are correct, and there will be no question where all the options are correct. That you can rule out. So, how many people are there right now in the session? Okay. Okay, once again, I just let me welcome once more the people who have joined in late at this live session of the NPTEL course Transition Metal Organometallic Chemistry from Principles to Application. This is the series of the first course in organometallic chemistry, and then we have two following courses which will be slightly of higher difficulty, or from covering different perspectives of landscapes of organometallic chemistry. So those two will run in the spring semester of 2025. So they are run parallelly to two courses simultaneously. And with these three courses together, you would get a full landscape of the domain of organometallic chemistry, a fuller perspective, which will sort of uh, kindle your interest in this area of organometallic chemistry. So if you have any question, please uh, type in, and we'll try to answer in the order in which we will answer them. And some of you have asked very good questions today. So if you uh, have any further, please type in, and we will answer them. I think, on a different note, I think this NPTEL course is are useful, particularly for from our perspective, to reaching out to the maximum part of the country, where the nothing the content is not compromised, and this exam is really difficult, and the maximum number of people can avail this course at their convenient time. So you don't have to travel to a particular university or institute and attend offline lectures to learn about the area uh, of your interest. You can directly uh, get access to the same content right from your home at your convenience time. And also these questions are the exams are extremely challenging and difficult, and when you do well in those exams, uh, you will get the certificates, and they right now those certificates are also uh, uh, valid in other institutes, and the due credit is given for passing or doing well in a NPTEL course. So in that way, using this online mode, uh, the outreach is maximized, and for a better purpose. So in that way, uh, I feel that this mode of delivery is also very important and has made a tangible difference in delivering the content across the nation to different parts of the country without in a mutual convenient way. So we don't have to travel everywhere to these give lectures, and student also doesn't have to travel to IIT Bombay to attend the lectures. Uh, in lecture 9, oxidative addition of alkyl halide uh, attacks in the trans position. Is there any particular reason? Now, see this also, I think, as discussed, that oxidative addition can be concerted, and it can happen in a stepwise fashion. I think the one of which is referred to is a stepwise addition. So if something happens in a concerted fashion, hmm, yeah. So this is a we No, not this one. No, oxidative addition in the stepwise. Can you also see, usually if it happens in a concerted fashion, you will always get a cis geometry, and if it happens in a stepwise fashion, you will can you for us to get to the content you are referring to in the PPT, can you tell us the time which you are alluding to in your question? And if it happens in a stepwise, then you will get a trans. And uh, which exact uh, point that you are referring to? Hmm. We are trying to get to the PPT that you are referring to in particular. But the general answer is, if oxidative addition happens in a concerted fashion, you will get cis, and if it's happening in a stepwise thing, you will get the trans. Could you find out what he's referring to? Lecture number 9, he says. Yeah. This is in lecture number 9, or? Yeah. Okay. What? 3 minutes. Okay. The other thing that by the time you get back, the other thing that I must say that uh, uh, there are two possibilities, as I said. One is the stepwise versus concerted. If it happens in concerted, you will get cis, and sometimes depending on the stability of the compound which is formed after by the cis addition, it may undergo rearrangement to give the stable conformation, which may be a trans. So overall, you may end up getting a trans which might have proceeded through a cis concerted mechanism, or you can if it happens via stepwise fashion, then you may end up getting trans, as that is the thermodynamically stable product. I hope I have answered the question that you have asked. If you have any further queries, or if you don't really if, agree to what being said, you can always send us uh, 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 through email, and we will answer your query further. Acha, I have about 3 minutes left, which I am told. So this session is going to end now, and I will close the session soon. We have about 3 more minutes. If you have any other question, please say. Partial marking will be there. Yes, for MSQ there will be, because uh, like if you get partially correct, if you don't get all the options correct, then you will get partial mark for the correct answers that you have gotten. Yeah, that is yes. Uh, oh, sorry, it is in lecture 10. Uh, they are digging up the lecture 10. But I think what you ask is very legitimate. Remember, this oxidative addition happens in a cis fashion. If it happens in a concerted way, you will get a cis. but the cis product may be unstable. It can rearrange it to give trans. That is one possibility. And if the cis product is stable, it will stay as cis. Okay. And the other thing is, if it happens in a stepwise fashion, then the trans product may be the stable one, and you will get it a trans geometry. So yes, thank you, Divya. Hope it is clear now. We have about 1 minute remaining. I wish you all the uh, luck, and it was very nice interacting with you, because we so far have been answering the queries through email, in the form we received them, but this is the first time somehow we could have a live interactive session. Please, only thing I can say is, please read the assignments and the content of the lectures very carefully. That and the main textbooks, if you want to do some additional reasoning, and I'm sure that you will, all of you will do well in the course. So with that, uh, we will close this session. I think we are almost at the end. Once again, what? Not 5 minutes. So that three was okay. So we actually, I'm told we have another 15 minutes. We will take more questions. Yeah. So initially, I was told that we have to close down in 3 minutes. So right now, I'm told we have another 15 minutes. No. Yes. Will there be partial marking? Yes, there is partial marking. That's what is said. Huh? What? Yeah, MSK partial marking is there. So we have another 15 minutes more. So we can take up more questions. So what is the number of people count now? 12. So some more people have joined in. So once again, for people who have joined in late, thank you for joining in. We are in the middle of this NPTEL uh, course titled Transition Metal Organometallic Chemistry from Principles to Application. Uh, by this time, I think you have gone through all the 60 lectures that were aired for this course, and the exam is due soon. So this is one of the three courses that are run in the area of organometallic chemistry. The other two will run in January, from January of 2025. And the purpose of these three courses taken together is to provide you with a holistic purview of this field of organometallic chemistry. So it starts from principles, applications, then it goes to the development in industry, industrial processes, as well as in biology. And organometallic chemistry, as I said, is a very important field which has been in existence for the last 50 to 60 years or 70 years or so. It has been seen its peak time, where many Nobel Prizes, as many as like 9 Nobel Prizes so far, has been conferred to this area or its related area. So that sort of says that every decade there had been one, at least on an average, one organometallic chemistry Nobel Prize a winner, which sort of says how important this field is uh, as far as the overall benefit to the humanity is concerned. Uh, so, uh, 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 like the, uh, one can sort of be inspired by the field, what it offers, and what are the current challenges in the area, so that one can take up these uh, problems and solve it for benefit of the humanity. So please type in your queries if you have any, or any other thing that you want to ask. It can be directly from the course, or anything related to the course, or anything beyond as well. I'll be happy to answer. So if there is no further question, we'll call. Uh, then we will close the session. So I once again wish you the best for your examination, and it was very nice interacting with you in the live session. With that, we'll close the session today. All the best. Good luck. Oh, there is one question. It says during the discussion of the Strock carbene in the example is said an electrophilic. Yeah, but it is, what is the subsequent below? Can we remove this? Remove this. This question, what discussion of Strock and Fischer carbene in NMR? The example with chromium is said as an electrophilic carbene. Oh, oh, but it is okay. So now it seems to me this example, what you were saying, uh, chromium to chromium to carbonyl uh, CpH2. This one, no? Uh, so, acha. Now you think that it is Strock carbene and it has been treated as a Fischer carbene. Is that what you are saying? Is that the question? Now, see, I think the basic definition is one is low valent metal center and the other is high valent metal center. Schrock carbene is are for high valent metal center, and Fischer carbene is for low valent metal center. Now, the example that which you are showing, CO5 chromium, so this is a low valent carbene. From that perspective, this is a Fischer carbene. From that perspective, But the primary definition of Fischer carbene, what they have stabilized, that had a carbene with a heteroatom substituent. In this case, there is no heteroatom substituent, and probably that is the reason you are referring to that as a Schrock carbene. But Schrock carbene are carbenes which also, in addition they have the metal center at very high valence stage, and the one that you have referred to here is a low valent metal carbene. From that perspective, I think this can be called as a Fischer carbene. Is that clear? Is that clear? And for this particular complex, the carbon 13 values are around 400 ppm, no? 399. Yeah. Acha, now, see, the one thing that you should bear in mind, uh, that the reactivity of the carbonic center, that the C carbene with two substituents, whether they have hetero atom or not, the reactivity of the carbene center would depend on how, to which to depend on the metal center to which that carbon center is bound to. Now, if the metal center to which the carbon center is bound to in a is in a low oxidation state, that means they are electron rich, then the carbonic center will also not be too much of electron deficient. They would also be electron rich. Now, if the carbonic center is bound to a metal center which is in high oxidation state, like in Schrock carbene, then the carbonic center will also be electron deficient to some extent, basically. So the metal center which is bound to the carbon center dictates the reactivity of the carbonic center. If the metal center is electron deficient, carbonic center is electron deficient. If the metal center is electron rich, carbonic center will be electron rich. Now, as the carbonic center changes from being electron rich to electron deficient, their reactivity to electrophile and nucleophile will change accordingly. And that is how the basic definition of Schrock carbene and Fischer carbene has arisen. So basically, see, from outsider's perspective, a carbonic center bound to a metal can be electrophilic as well as can be nucleophilic. So it's very confusing, no? How come a carbonic center behave in exactly opposite way? Now the answer to that is it depends on how the carbonic center has been stabilized by the metal ion. If the metal ion is electron deficient, the carbonic center will behave in one way. And if the metal ion which is stabilizing the carbonic center is electron rich, low oxidation state, then the carbonic center will behave in other way. A very good question, Dibba. If you have any other question, please do ask. These are, what should I say? These are very fundamental questions that you are asking, and these are good questions. Ajay, now what these are two broad classifications, like two extremes. One we like depending on this a person who has synthesized them to honor them. One is called Fischer, who has synthesized Fischer carbene. The other is Schrock, which by the way, both of them got Nobel Prize. Schrock is also a Nobel laureate. Fischer is also a Nobel laureate. Now, there will be compounds which are in between, like some metal center. They may not, they are, if you look at the carbon chemical shift and all, they will come somewhere in between. They are neither fully struck or not fully, and that's part of the reactivity space. landscape. So there will be carbonic center, which may be a amphiphilic, like they're electron rich, electron deficient both. So they somewhere appear in the middle. So not all the metal carbines can be classified in any these two categories. There can be something which is in between as well. Actually, see, from the carbon perspective, no, the carbon doesn't know whether I am Fisher or I am Struck, which group I belong to. It's an intellectual jargon. It's just that we classified those reactivity as being Struck or the other being Fisher. Carbon will react as it's in its own way. It doesn't know which category or which camp does it belong to. So, do you have any other question? Okay, so with that, if there is no further question, let us once again come to the end of this live interactive session. I once again I wish you all the best for your exam. Study hard, do well, and hopefully in person there will be some opportunity for us. We'll meet and we can take up from where you have stopped today. Will that be all the best and good luck for your exam.